Alright, welcome to another WebGL Playground Tool tutorial. In this video, we're going to be talking about building shapes programmatically. If you are coming from the first video, you're going to have all the tools necessary to help you follow along with what I'm talking about. But if you didn't watch that video, and anything in this video doesn't really make sense about drawing order, vertices, colors, anything like that, you can check out that video, which I'll link in the description. So every shape and or volume that we want to make can be done with triangles, and because the playground was created in a way such that everything has to be a triangle, this is kind of what the idea we're going to follow. Now this might not be intuitive for every shape or volume that we want to think about, so we're going to want to plan this out. We're going to want to plan this out for a given shape that we want to work with before we dive in. So let's think about a square. A square, to be centered at our rendering context, is going to have to be centered at an XYZ of 0, 0, 0. And since we're working with the square, every side has to be the same length. So in order to actually make this shape, these 4 vertices on screen are the ones that we're going to work with. And it would look something like this. So you can see at the top right of your screen, we're going to have an x and a y coordinate of 0.5, while at the bottom left of our screen we'll have x and y coordinates of negative 0.5, and we'll have the other variations of the 2 points there. Now, since we're drawing this shape with triangles, we can't just use 4 vertices, so we're going to have to reuse some of those vertices in order to make triangles out of this shape. So maybe intuitively, we're going to break up this square by drawing a line from one diagonal to another, and now you can see 2 triangles here. The first triangle can be defined by the vertices A, B, C, and the second triangle can be defined by the vertices A, C, D. So now we have a square that is represented as triangles, and if we recall our knowledge from the prior video about drawing order, we are going to need to draw them in a kind of counterclockwise fashion. So we will start at A, and then draw B, and then draw C, and then we will draw A, then C, then D. So let's open up the playground and see what this looks like. Okay, so like we talked about, we're going to have 4 vertices. So what I'll do is code those up here. So the first vertice is A, and that vertex has a x coordinate of negative 0.5, a y coordinate of negative 0.5, a 0, 0, and a w value of 1. And now we're going to have 3 more vertices that are just like this. We call them B, C, and D. So let's go ahead and change that there to B, C, D. Now if you remember, B was at the bottom right of the screen, so its x value would be 0.5, but its y value would be negative 0.5. C was at the upper right, so the x and y values here are positive. And lastly, D was at the upper left, so it's got a negative x value, but a positive y value. If we go over to the Colors tab, we're going to use a programming trick called a loop, where we declare kind of something that iterates, and we'll initialize it to be 0. And a little trick here, the Colors tab knows about the Vertices tab. So we can actually use the property vertices.length, which tells us how many objects are in that vertices array. In our case, it's going to be 6. And we can iterate up to all of those. And to start here, we're just going to make a red square. So what I can say is just colors.push, and we'll do an R, G, B, W, something along those lines. And if we just go back here, we need to push all of these vertices onto the array. So we'll say vertices.push, and we're going to do 6 of these. So 2, 3, 4, 5, 6. And like we talked about in the PowerPoint, we're going to push them on A, B, C, and then A, C, D. So if we hit load, we can see that red square is centered at 0, 0, 0. So let's move back to the presentation. and we'll start talking about a more complex shape, and that's a circle. So the question is, how do we draw a curved edge with a collection of triangles? There are lots of ways to do this, but the approach that I'm going to take requires some creative mathematics and programming. So if we're going to kind of ease us into this idea, let's look at a pinwheel at the start and see how does a pinwheel actually relate to a circle. So at the bottom right here, I've drawn a circle and I've kind of quartered it. And I've drawn a triangle in each of the quarters. So as you can see, these triangles kind of fill the area of this circle, but there's all this blank space in here. So we want to fit as many triangles as possible into this circle, and we can do that by limiting the height of this triangle and using this edge of each triangle to very closely lay along the outside of the circle. Now we can limit this height by modifying the angle of a given triangle, and if we have a very small angle, we can fit a lot of triangles within this circle. So this is kind of the idea that I'm talking about. So this is the shape that we saw on the other slide, but we're gonna wanna make these triangles have a smaller angle, and as you can see, as we make this smaller angle, we're able to fit more and more and more of these triangles within this circular shape. And if we have enough small triangles, eventually it will look like a circle without actually being a circle. So just some quick trigonometry as review. So if we have a right triangle down here with an angle theta, and for the sake of this demonstration, our circle radius is going to be 1. That will fill the whole canonical view volume. So if we're going to calculate the x and y values of this triangle, the x value is going to be the radius, which is 1, times the cosine of this angle. And the y value of this triangle, or its height, is going to be the h value, which is 1, times the sine of theta. Now if we were going to convert those into vertices, remember A is going to be centered at the origin, so that's going to have an x, y, and z value of 0. B is going to be the length of this side x here, and it would have an x coordinate of this length with no height and no z value. And lastly, y for C is going to have a x value similar to B, but it's also going to have this height y. So that would be an xy with no z and that w value of 1. So when we talk about stacking, so if we go back a few slides, this is what we're referring to. How are we going to rotate these triangles about the circle such that they kind of stack up nicely? So if we were to draw one triangle and then want to draw one similar to it, if we look at the combination of these two angles, it's actually 2 times one of those angles. So what we can do is just find the sine of this value right here, and that will represent our new height, and we can find the cosine to represent our new length down here, and we can use that xy combination to find this new value of c. And so if you look at this triangle right here, this base of this triangle doesn't exactly stretch out to the width of this, or to the length of this hypotenuse. So what we're going to end up doing is just assigning this value to be the old value that we had calculated from our first triangle, and then we can have a more contiguous pattern along the edge. So our approach is going to be draw our first triangle, then save that C vertex in B. We're then going to increase our angle, so now we are representing kind of 2 triangles here, and calculate our new C value, which would be up here. We'll call it C prime. And then we will draw this triangle, and then we will save that C prime vertex as our B, and then increment our angle, so then we'd have kind of 3 theta, and then we would calculate that new xy coordinate of C prime, draw the triangle, So as you can see, this is an iterative process, and just like we did with assigning colors to the square, we can do this iterative process with a loop. So the logic of that loop would look something like this, where we do some variable setup, draw our first triangle, or excuse me, set up our first triangle, and then within the loop we will be drawing a triangle, saving the lead vector in the vector that's following, so the lead vector would be C and the following vector would be B. Then we would recalculate our angle and recalculate our lead vector, and then we would redraw those triangles again, and we would loop over that until we complete the circle. So let's pull up the playground, and we will attempt to do that here. So the way I'm going to structure this code is going to be all based off of one variable, which I will call num triangles. And when I say num triangles, this is going to be the number of triangles that I have in my circle. So we're going to do a couple more declarations here. We don't really need to, our origin's never going to change, so I will just declare it there. Now, I'm going to use that num triangles variable to kind of determine the theta, or that angle that's going to be within each triangle. So we're going to say theta per triangle. Now everything that we do, we're going to be using the JavaScript math library, which operates in radians. So if you reach back for that unit circle knowledge, we know that a circle has 2 pi radians within one rotation. So we're going to say 2 times math.pi divided by the number of triangles we have to get the angle of each small triangle that we're going to draw. Lastly, we're going to be incrementing this theta as we go, so I'll make a variable called running theta, which starts at a value of theta per triangle. So now we're going to set up our first triangle, and to do that we're going to say x equals the cosine of running theta, and we're going to say y equals the sine of running theta. This is grabbing those x and y values that we talked about, and we're going to set our following vector to, this is representing the point B from our slides, to be x, 0, 0, 1. And then lastly, our leading vector is going to be, this is representing that C point from our triangle in the slides. Our leading vector is going to have the xy component. And now we are going to use that I value that we declared right here to do our iterating. So for I equals 0, I is less than the number of triangles we want to draw. Increment I. So we are going to draw our triangle. That's the first step of the loop. So we're going to have 3 push statements. Excuse me. And these 3 push statements are always going to start by, we're going to do them A, B, C. So from the slides, A was the origin, B was the following vector, and C was the leading vector. Now, we're going to assign the leading vector to be our new following vector. And we can use this 3-dot operator, which allows us to take all the values from leading vector, and copy them into an array, which is what we're calling following vector. Now we're going to increment our running theta by theta per triangle. And lastly, we're going to calculate our new leading vector. So that is going to be an array. The x value is going to be the cosine of running theta. The y value is going to be the sine of running theta. Our z value will be 0, and our y value, or our w value, will be 1. So now that we've done that, let's go back over to the Colors tab. So now we can use a similar trick to what we did the first time, where we used the length of our vertices array to kind of draw in these colors. So let's just do a colors.push, and to start here, we'll make a red triangle. So RGB that. And let's give it a load. Hopefully I typed in everything correctly. Let's see what happens. Okay, so it looks like I made an error somewhere. So what we'll do, luckily I have this code off to the side, so I can just copy it on in. There we go. And we'll take this colors code again. Retype it in real quick. Okay, that should work. So let's go ahead and load this in. There we go. That is a circle. So it's not immediately apparent what's going on with this circle. So we're going to change the color code just a little bit, and then we can play with this num triangles variable that we've set up to kind of see the process that's going on. So I have a little bit more of complex color code where we start at I = 0, and we're still going to go up to vertices.length. But we're going to increment I by 3 in each iteration of the loop, and that will be apparent here in just a second. So we're going to, declare some variables here that are going to represent random colors. So I just go down. We can use the random function, which will generate a number between 0 and 1 inclusive. So we're going to declare a random red, green, and blue variable, and then we're going to make a color array that is random red, random green, and random blue. Value of 1. Put an equal sign in there. And then we're just going to push color onto the colors array. Now, since we're incrementing by 3, we're kind of generating the same color, same random color for a given triangle. And so if we go ahead and run this, instead of this being red, this should be a multicolored triangle. There we go, multicolored circle. So we can see all the triangles that we have going on here. So what I want to highlight, we'll take this 64 and we're going to cut it by 4. So this should end up drawing 4 triangles per quarter of the circle. So there you go. So as we can see, we start with this green triangle here, and we slowly rotate it around to draw all of the vertices of this circle. Now, if you notice here, there's this little bit of overhang, and that's from the initial setup of the first triangle. Now, all of these triangles where we have these two sides, we want them both to be of unit length 1, so that they kind of all touch the outside of this circle. So what we can do here is take this following vector, which is just the first vector that we use to set up, give it an x value of 1, and you'll see this kind of bump over so that it mirrors the rest of the circle. Now, you can do as many or as little as you'd like. So if we do 8 here, for example, you'll see 2 per, and this doesn't really look like a circle, but as we start to increment this value, 32 starts to really look nice. And we can go as fine or as not fine as you like. If we go up to 128, you can really start to see this process take into effect. And the more triangles you add here, the more round that shape is going to be. We can do something crazy like go all the way up to 512, and you'll see all these fine little triangles in here. Just like with all the other models you can make in here, you can do a begin rotation, and we can see those vertices start to spin around. So yeah, that's kind of how I like to draw circles with OpenGL with just the vertices and colors array. Hopefully that helps. In the end, I'll end up posting this code online so you don't have to keep redrawing this shape. And yeah, thanks for tuning in. More videos like this to come. And yeah, thank you.